All right, so 49 has a bullet being shot at 340 meters per second. So we'll do velocity in the x. And no y velocities, shot perfectly horizontally. We know that this velocity is going to be constant. And the piece of information that's kind of vital is what happens on the other side with the window over here. So we know that going 340 meters per second, it will travel 6.9 meters. So 6.9 meters at 340 meters per second means that it took 0.02 seconds to fall that 0.5 meters. So now we can go to our other kinematic equation and say y equals v naught times t plus 1/2 at squared. Now that we know it's 0.02 and 0.02 and 0.5 and 9.8, we can solve this for what its initial y velocity was right up here. Okay, so 0.5 minus 1/2 at squared equals v naught y, and we'll divide that by t. Gets rid of one of those, and we end up with 24.9 meters per second. So now we just have to figure out how far something has to fall to get up to that speed in the y direction starting from rest. So I get v final squared equals v initial squared plus 2ax, and x in this case is the height. But we have to be careful because this is the speed at the top of the window up here. So at the end of this I'll find h, but I'll want to add 0.5 meters to finish that fall. So I had no initial y velocity. A is 10. So I have v final squared divided by 20 equals h. So 24.9 squared divided by 20 equals the height. And then I'll take that height and add 0.5 meters, and I get 32.1 meters. Now I can figure out the time. For part B of this one, I have to figure out how far D is. So I'm going to take this distance to fall, y equals 1/2 at squared, and find the total time to fall that far from rest. Solving that for t, I get 2.56 seconds. I then say that 0.02 of that was going through the window, so I'm going to take off 0.02, and I end up with 2.54 seconds. Distance equals velocity times time, so I end up with 340, my x velocity, times 2.54, and my d equals 864 meters. So there's my two answers.